I'm Rajesh Uppal, Director IDST. We bring sharp insights and foresight on defense, security, and emerging tech. Let's dive in.
Space is the most unforgiving environment ever explored by humankind. Step outside a spacecraft unprotected, and your blood would boil in seconds. Temperatures can swing from minus 250 degrees Fahrenheit in shadow to over plus 250 in sunlight. There's no air to breathe, no pressure to contain your body's fluids, and invisible radiation constantly streaming through the void. To survive, astronauts rely on one of the most sophisticated life support systems ever created, the spacesuit. It's not just clothing, it's a personal spacecraft designed to recreate Earth-like conditions around a single human body. But not all suits are the same. Inside a spacecraft, astronauts wear IVA suits, short for intravehicular activity. These are lighter, more flexible, and act as a last-line emergency system if cabin pressure suddenly drops. Step outside, however, and you need an EVA suit, an extravehicular activity system. It's a self-contained environment capable of keeping someone alive for up to 8 hours in the vacuum of space. You can think of it like this. IVA suits protect life inside the capsule, while EVA suits let humans live and work beyond it. Today, the global spacesuit market is taking off faster than ever. Valued at about $1.02 billion in 2025, it's projected to reach $1.44 billion by 2030, growing at more than 7% a year. And this time, it's not just NASA or Roscosmos driving demand. Commercial space tourism, private lunar programs, and national exploration initiatives are all fueling new orders. SpaceX's Polaris Dawn mission in 2024 already made history with the first commercial spacewalk, proving that private suits can now match NASA's performance standards. North America still leads thanks to NASA's Artemis procurement, but Asia-Pacific is the fastest-growing region as China, India, and the UAE ramp up their human spaceflight ambitions. What makes these modern suits so extraordinary is how they merge advanced engineering, material science, and human physiology into one wearable machine. Every EVA suit must survive conditions no human body could ever endure, from razor-sharp lunar dust and micrometeor impacts to radiation storms and rapid temperature shifts. To handle that, engineers layer fabrics like Kevlar, Nomex, and Teflon for puncture resistance. Beneath them lie aluminized mylar sheets to reflect radiation and graphene-infused aerogels that keep the astronauts' temperature stable whether they're in burning sunlight or deep shadow. These suits aren't just tougher, they're smarter. Augmented reality visors project mission data directly onto the helmet display, while biometric sensors monitor oxygen, heart rate, and pressure in real time. Artificial intelligence controllers can even adjust life support systems before a human notices a problem. In other words, your suit now helps keep you alive by thinking ahead. Across the world, competition is heating up. The United States continues to dominate, powered by NASA's multi-billion-dollar XEVS contracts with Axiom Space and Collins Aerospace. In Asia, China's Feitian suits and India's upcoming Gaganyaan models are setting regional benchmarks, while Europe's Airbus is experimenting with 3D-printed titanium joints for future lunar missions. Russia, meanwhile, is upgrading its Orlan 5 suits for extended Mars analog operations. What was once a purely national enterprise has become a truly global race, a renaissance in wearable space technology. And the innovation doesn't stop at protection. The next generation of suits is being built for permanence, for humans who will live and work off-world, not just visit. NASA's AxEMU-built AxEMU suit offers rear entry access, dust-repellent fabrics, and components that fit 90% of astronauts. MIT's BioSuit takes a completely different approach, a skin-tight mechanical counter-pressure design that replaces bulky air layers with tension fabrics, dramatically increasing mobility and cutting weight nearly in half. Imagine a future suit that harvests your movement for power, recycles carbon dioxide back into breathable oxygen, or uses micro-exoskeletons to reduce fatigue during Mars exploration. These aren't distant dreams anymore. Prototypes already exist in testing labs. Each breakthrough brings us closer to a future where a spacesuit isn't just a protective shell, but a true extension of the human body, part biology, part machine. The astronaut no longer merely wears the suit, they become one system, evolving together to survive beyond Earth. From the freezing void of lunar night to the blazing daylight of Mars, spacesuits remain humanity's most intimate connection to survival, the fragile boundary between life and the infinite. Once government-issued gear, they're now the foundation of a billion-dollar industry, bridging science, commerce, and exploration. As we return to the moon, prepare for Mars, and open low Earth orbit to civilians, the spacesuit is no longer just protection. It's infrastructure, the first step in building a permanent human presence beyond our planet. Because before we construct bases or cities in space, we'll perfect the suits that make them possible. Thanks for watching. Subscribe, follow, or visit idsth.com for more cutting-edge defense and tech insights. See you in the next one.